right, hello, everybody. All right, let's just start. It's a math blitz, so we're just going to go ahead and start. So you have 7 minutes to answer this question. Go. From looking at your faces, I think a lot of you are done. So we're going to stop it in 1 minute from now, which is only 5 minutes total. All right. Hello, everybody. I am Michael Ehrman. I'm the creator of the Amber Book. We have helped about 15,000 plus study for these exams. We have an online animated course and a workbook and a series of flashcards. And what we're going to do today is we're going to, people ask me all the time, like, can you just go through a bunch of math problems? So I decided this would be a good thing to do. Let's just go through a bunch of math problems because I think there's just a lack of memory of how to do some of this stuff. And it's just been a while for some of you. And for some of you, maybe this is stuff that kind of makes you allergic to begin with when you see a bunch of numbers. And so what we're going to do is we're going to fairly quickly go through 4 or 5 questions. And then if you get left behind, there's a type of person who freaks out when they don't understand something and they get left behind, and we move on to the next person. And that person is called an architect. But I need you to put that aside today. And if you have trouble with one, just move on to the next one, and then we'll figure it out from there. Now, this is pretty typical of the type of math problems you'll see in the exam. People, I think, or they suspect, or they fear that the math that's going to be on the exam is complex, and it's not. It's sometimes complicated like this, but it's not usually very complex because the exams are set up so that you can take each question and do it in 2 minutes if it's a multiple choice or a non-case study, and 4 minutes if it's a case study. So every exam works out so it has about the right amount of time, where if you take 2 minutes per non-case study and 4 minutes per case study, that should be your pacing. And so NCARB recognizes that it probably shouldn't take you more than, I don't know, 3 minutes or so to do a problem like this. So what they'll often do is they'll do some of the problem for you, which is, if you noticed what happens here, which again freaks some people out who are uncomfortable with positive ambiguity, and those people are called architects as well. And so we're going to find that there is some content that's in the paragraph, but not in the table. There's some content that's in the table and not in the paragraph. Some content that's in both, and some content that's in one or the other that you actually don't need. That's normal too. There's almost always at least one distractor that you don't need. And there's no reason to panic. I see all the time people get freaked out. They're like, but why did they tell us it's on a sloped site if it's not important? And the reason, of course, is because that's what makes a good exam. You don't put everything in a bow for a person if you're trying to test their knowledge. You give them more information than they need, and you have them help kind of sort through it. Now, typically, there won't be more than one thing more than you need, and that's the case here. So what we have here is that a client has hired an architect to design a temporary fairground structure, compensating him at $20,000 stipulated sum. Now, stipulated sum means lump sum. And this is our PcM. We're going to kind of move through from beginning to end. So we're starting with a PcM question. We'll go to PcM and so forth. And 20% of which will be set aside as profit, and the remainder to be used on labor. The project is, that's also an NCARB thing. It's just kind of oversimplifying, and that makes sense again if you're testing people and you don't want to send them too down the weeds with how much is set aside for a particular a consultant or like a structural engineer, and you don't want to kind of get into like how much we're going to charge for a roll of drawings. We're going to just kind of simplify it. And the remainder to be used on labor. The project is at a 20% CD stage. It's actually pretty much irrelevant to the question. The firm manager has determined that completing CDs requires 18 more hours of the principal's time and 12 more hours of the project architect's time. In the budget, that leaves a maximum of blank more hours for the project architect to engage in bidding and construction administration. So what does that mean? Well, that means we've spent a bunch of money. We have a fixed fee, and we have some more to go through CD. And then the question is, how much can we allot after that? So what do we have? Well, it's given in the table, but not in the paragraph, that we've already spent to date $11,500. And it actually did a bunch of calculations for us. This is not unusual at all. We have 18 more hours to complete CDs. We're given here that we have 18 more hours for the principal's time, and 12 more hours for the project architect's time is given here. Now, up in the paragraph, we're not given how much they're paid, but we're given that down here. And so it's already calculated that the expenditure for the next 18 hours of the principal's time, this right here, is going to be 18 times 120, and that's going to give us 2160. And that the extra 12 hours for the project architect to finish is going to be 12 hours times $75 an hour, and that's $900. And of course, this per hour is what we're charging the client and what we're internally using to figure out how much time we have. But in reality, it's quite likely the project architect is making something less than $75 an hour. So, and it's also added these two up, though in a, albeit a little bit of a confusing way. So we have 30 total hours to finish CVs, and that's $3,060. That's the addition of these two. So we've already spent $11,500. Well, let's start. Our total project staff budget, well, again, it told us that we're paid $20,000, but that 20% is going to be for profit. So $20,000 times 20% is equal to $4,000. So there's going to be $4,000 as profit, and so we have $16,000 left over to pay our staff, and that's given too. It's already kind of given. So we're starting with $16,000. We're starting with this much. Let's make a bar graph of it. We're starting with $16,000, and then we're going to shrink that bar graph down because we've already spent $11,500. So we're going to subtract 11,500, and then we need 3,060. We need to go down to 3,060, and that's whatever's left in that. That's what we have to pay for bidding and construction administration, which is now technically called construction phase services, but that name hasn't really caught on, I think, the way that the folks at the AIA would like. Why did we change the name from construction administration to construction phase services? Go ahead and put your guess on the chat and see if you know. All right, so we're going to take this 16,000. That's how much money we have to spend on labor. And we're going to subtract what we already spent before we got to 20% CVs, before we got to today, $11,500. And that's going to give us, let's see, that's going to give us $4,500. And then we need to subtract 3060, because that's how much we need to finish the project. And that's going to give us 1440. There's a weird way to write 1440, but that's going to give us $1,440. Now, what's really important is that you never look at numbers ever, 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 including on the exam. You never, ever look at numbers as symbols. They have real meaning. And so what we're saying is we started with 20,000, 4,000 the firm took to profit. We have 16,000 for labor. We already spent 11,000. We still have to spend 3060 to finish the drawings, and that's going to give us 1440 left over. Now, that wasn't the question though. The question wasn't how much money do we have left for bidding and construction administration. The question is how many hours do we have left for the project architect to engage in that activity. So we have $1,440, and we have the project architecture at $75 an hour. So we can take $75 and divide it into $1,440, and by doing so, we can figure out how many hours we have in total, and that works out to be about 19 hours. And that's our answer. You could do 19.2, or you could go out as far as you need to. In reality, people always stress out that the exam is going to mark them wrong if they don't understand whether to round up or down, or if they, how many decibel points do they have to go, and so forth. And I'm here to tell you, you don't have to worry about that. Anytime there's a numeric answer and there's going to be a range. And so, the right answer may be between 19 and 19.25 in the background. So if you got the math right, you will get the problem correct. NCARB messes up a lot of things, but they don't generally mess up this. At least I haven't heard any stories of that. All right, a couple other issues. Number one, so they changed from construction administration to construction phase services because, well, your honor, just imagine yourself on the stand and being what do they call it? What do they call it? Help me, not
Cross-examination.
multiply, cross-examined. And I kept thinking cross multiplied because we're doing math. So you're being cross-examined, and they said, ladies and gentlemen of the jury, this is someone who had a contractual responsibility to do construction administration, and you can see that clearly the welds were not up to what the architect had specified, and so you need to find the architect guilty, in this lawsuit for the collapse of this particular building during the earthquake, because she or he in this case offered to provide us with construction administration, and this was not administered properly. So construction phase services, I think, for lay people and the jury, just make it a little more clear that we, the architects, don't get paid much, but we take on almost none of the liability that the builder or the owner takes on. All right, again, never just end it with 75. I'm sorry, never just end it with 19. What does that mean? Well, it means we have 19 hours. We have 19 hours left to give to this project after we're done with CDs. Because a lot of times, if you make a mistake, if you add a zero here, then you're going to come up with something like 1.9 hours. Or if you had 2 zeros there because there's a .00 because it's dollars, you're going to come up with 0.19 hours, and that doesn't feel right to finish the project. So that will give you a heads up. Wait a minute, 0.19 hours to finish a project? That sounds ridiculous. To go through construction administration, to spend like 10 minutes on construction administration. Now, if this seems fuzzy, if you're like, well, how do you know that it's going to take 18 more hours of the principal's time and 12 more hours of the project architect's time to finish? And by the way, what if we need more than 19? What if it does need that, but we need more than 19 hours at the end for bidding and construction administration? Don't we provide that? Well, what NCARB and the AIA and the profession at large is trying to do is get you out of that mindset that we all have, where we're like golden retrievers and we're just so happy to have our input on a building that we'll work as many hours as it takes to get the building perfect. Now, I happen to think you should work as many hours as it takes to get the building perfect, but I understand the other argument too, because if you want a profitable, stable firm to be sustainable and survive the next recession, you need to clearly start seeing fees as hours and see no daylight between the idea of fees and hours. So you need to estimate that we need 18 hours from the project Daisy, I'm going to see if I can mute you. Oh, did you? Okay, someone did that. We need 18 hours from the principal and 12 hours from the project architect. And you say to the manager, but how do you know? Well, they don't know, right? She doesn't know. But you keep making revised, more and more accurate assumptions based on your knowledge, because not having an assumption is an assumption. Like the number is not zero, the number is not infinity. So not having an assumption is an assumption. So what NCARB and the AIA, with the whole idea of the PcM is trying to do is get architects to start thinking of time as money, and to start thinking of budgets as important, and to start thinking of deadlines is important. And part of that is to start seeing hours and these kind of schedules as a single thing. All right, that concludes our first one. We're going to do our second one. This time I'm going to give you a little less time, both because you finished it quicker last time, but also because the first time I wanted to just give people a chance to settle in, get some paper and so forth. So this time I'm going to give you 5 minutes to do this next question. You have 50 seconds left. So I think that there's a common misconception, and those of you guys who have taken exams before can put in the chat and tell me if in your experience I'm right or wrong. But there's a common misconception that the math on these exams is complex, and some of it is, but very little. And so people will kind of freak out about trying to use, derivatives to come up with a compound moment for a beam that has a cantilever and a point load and a uniform load. But in reality, most of the math is actually pretty arithmetic and pretty algebraic, and is very much in the wheelhouse of, frankly, like 7th grade math. It's just very complicated. So it's not very complex, most of it. Some of it will be, but most of it is very complicated. And that's what we're going to work on here, is just kind of getting our, cracking our knuckles in the world of arithmetic and algebra. So in this case, a museum requires a 2,000-foot long driveway, 20 feet wide. Now think about what that means. It's a 2-kilometer driveway. That's like more than a mile. No, that's not more than a mile. But that's almost, it's a half-mile long driveway almost. So it's a long driveway that we're going to build from the road to this museum. Something like, have any of you guys been to Glenstone? If you live anywhere on the East Coast, you absolutely must go to Tom Pfeiffer's Glenstone Museum. Like, you have to do that right after we get off the phone.
Great.
It is unbelievable. But anyhow, that's got a long driveway as I remember it. And the drive will be bounded on the 2 long sides by a vertical concrete curb and gutter. The construction requires 2¼ inches of asphalt over 6 inches of gravel aggregate base, and the subgrade will consist of existing on-site fill with a geotextile. Given the values in the table, what is the total cost of the driveway materials? All right, so we're given that asphalt is $275 a square foot, and gravel is $45 a cubic yard, and a geotextile is 70 cents per square yard, and the concrete curb and gutter is $10.50 per linear foot. And really what this question, and the difficult part of this question, besides keeping your numbers straight on the whiteboard, but the difficult part about this question is actually just being able to move back and forth comfortably between different units. So what do we have? The asphalt is $2.75 per square foot. So what I'll do is I'll put all the dollars over here, and then I'll kind of divvy up the top left. I'll divvy up the row on the top to kind of figure out how we got to each one. So we want to figure out, it's $2.75 per square foot. Now, we know that the driveway is 2,000 feet long and 20 feet wide. So we have 40,000 square feet. And we're going to multiply that by $2.75 per square foot. And we're going to get $110,000. So $110,000. So that's what we're paying just for the asphalt. That sounds like a lot to me. Let's go on. The gravel is $45 per cubic yard, $45 per cubic yard. So now we have to know a couple of things. One is, how many, let me ask you, go ahead and put in the chat, how many cubic feet in a cubic yard? Go ahead and put the number in the chat. Oh, look, we see the problem. 27,399, 2727. And the answer is it's 27, because a cubic yard is 3 feet by 3 feet by 3 feet. And so it's not 3 cubic feet in a cubic yard. It's not 9 cubic feet in a cubic yard. It's 27 of these, because there's 3 in each dimension. So Because of that, that is a big one to screw up on the exam. It will come up over and over and over again. So that is definitely something you want to be comfortable moving between cubic feet and cubic yards. So what are we talking about? Well, we have 6 inches of gravel, and we're going to have to change 6 inches to feet because everything we're doing here so far has been in feet. So we have 40,000 square feet of driveway, and we want to figure out if we have 40,000 square feet of driveway and it's a half a foot down, how many cubic feet do we have? Well, we're going to take 40,000 square feet and we're going to multiply it by 0.5 feet, and that's going to give us our volume, length times width times height. So our length is 2,000, our width is 20, and our height is a half to come up with a volume, and we'll get 20,000. We'll get 20,000 cubic feet. Now, that's not what we want though. We want to figure out how much the gravel costs, and it is $45 per cubic yard. So the next thing we're going to have to do is we're going to have to turn 20,000 cubic feet and we're going to have to divide that by 27 cubic yards per cubic foot. Because obviously, just think about it. If you forget on the exam whether to multiply or divide in this situation, there's obviously going to be fewer cubic yards than cubic feet for a given amount of volume. So you can surmise and guess that you probably need to divide. So if we run this out, and you can take your calculators if you haven't already done so, and you can do 20,000 divided by 27, and you wind up with about 741 cubic feet. I'm sorry, cubic yards. That's how much gravel we need. And we're have to then multiply that by $45 per cubic yard. And that's going to be equal to 33, oops. That's going to be equal to $33,333. It's one of those numbers. All right, next, the geotextile. All right, the geotextile is, this one's going to be per square yard. And you remember we have 2,000 feet by 20 feet wide. So we have 40,000 square feet. But we need to change that to square yards. And again, we're going to divide not by 27 because that was per cubic yards, and we're not going to divide by 3 because that's for linear. That's changing linear feet into linear yards. We're going to divide by 9 because if we I'll just do it over here. If we have an area that's three square feet on each side, that's 9 square feet for a square yard. So we're going to take 40,000 square feet and we're going to divide it by 9. And what we wind up with is 4444. A lot of these repeat numbers on this one. 4444 square yards. All right. And then now we know that it's 70 cents per square yard. So we'll multiply that number by 70 cents. And we wind up with $3,111. So $3,111. All right. Finally, we have our concrete curb and gutter, and understandably, each one of these is understandable. Asphalt is per square foot. That seems reasonable. Gravel is per cubic yard because they don't know how deep you're going with the gravel. So that sounds reasonable. Geotextiles is per square yard. Again, we do that with fabrics, square yards. And the concrete curb and gutter, that's going to be per linear foot because obviously it's going to go on the perimeter of the 2 long sides. So in this case, we have 4,000 linear feet because we have 2,000 on each side. So I'm going to do it over here. We have 4,000 linear feet because we have the perimeter on both sides of the 2,000 foot long driveway. And we're going to multiply that by $1050 dollars per linear foot. And we're going to wind up with $42,000. All right, so we'll add $42,000. Now, as always, do not look at these just as numbers, just kind of magic, symbols. These are real money. This is real money we're talking about. So what do? We say, okay, where's the big cost? Well, the big cost is in 3 of the 4 things. It turns out the geotextile is pretty cheap, but the asphalt is very expensive, and the gravel and concrete curbs are pretty expensive as well. So we can add these all up, just straight up, arithmetic in our calculator. And I'll give you guys a second to do it while I'm talking, but it winds up being pretty expensive. It winds up being $188,444. Now, that tells me that if we had put the museum closer to the road and required a shorter driveway, I'm not suggesting you should do that. It's a wonderful thing to set it back, but I'm suggesting that you should have your eyes wide open that that it's going to cost an extra $150,000 or so to tuck the museum way back in the site relative to if we had the museum fairly close to the road. Now, several of the exams have in their requirements or in their kind of categories something about cost, and this is often how they do it. They'll just do something like this to talk about cost. That baby is ridiculously cute. They'll have something like this to talk about cost. So it's not usually that you have to memorize what things cost, although I'll give you a trick for that in a second. Can you guys still hear me? My phone rang and it went into my headphones. This is how they're going to ask you a lot of the questions about cost. So basically, you're going to give you something pretty basic and straightforward like this, and see if you can move back and forth between square feet, cubic yards, square yards, and linear feet. And you should be comfortable doing that if you're going to take the exam. Now, if you have other types of questions on the exam, and it asks about, you're trying to decipher what's most expensive or what's cheapest, it's impossible to know the answer. But in almost every case, the thing that is most commonly seen is going to be cheaper. So if you go to your nearby multifamily student housing complex, it's going up. It's going to be OSB on the outside, not plywood. And so OSB must be cheaper than plywood. You can just assume it. If you look at low-income housing, it often has vinyl siding. Vinyl siding must be cheaper than stone, which you probably knew anyway, and so forth. So whatever you see the most, if you're not sure, when in doubt, whatever you see most commonly on construction sites is going to be cheaper, and whatever you see least commonly in buildings or on construction sites is going to be more expensive. All right, let's go ahead and do the next question. You're going to have 5 minutes again. Ready, set, go.
Can I ask a question about this one that
Sure.
we just did? The way I was reading the question, I read that the geotextile was existing. Ralph explained that it probably shouldn't be, but the way that sentence read told me that it was existing, and I thought it was a trick question.
Yeah, it's not. And I mean, it wasn't intended to be. Existing on-site fill with a geotextile. I mean, you wouldn't really have an existing, I can't imagine a scenario where you'd have an existing geotextile, but one would hope that NCARB would catch that kind of thing and make it less confusing. But we all know that that doesn't happen. There's, and also there's some common sense involved. The geotextile doesn't just, sit under a site at a, as a driveway for a new museum. I mean, I can imagine if they said it was a renovated museum or something, and they were repaving it.
Even then you do the site work and it's
gravel.
torn up, and yeah.
Right.
So I mean, badly worded questions are not a new thing, right?
Yeah. I wish now that you say that, I wish
like leave it like it is.
Yeah, I wish I had worded it differently, because we should strive to be clear. But in general, there's not as much tricky stuff in the exams as you think. Usually, if there's something tricky, they have a point. So their point, the NCARB's point is they want to know that that if you have two different metals that are in contact with each other in the presence of rain, one of them will corrode the other. That's their point. That would be the tricky part. Or NCARB wants you to know that that if you have absorbing materials in a room, sound absorbing materials in a room, that does not help with noise control and sound isolation between rooms, or doesn't help much really. And so those are the kind of things, if they're going to do a tricky question, they want you to understand the exception to the rule, or understand the common misconception. And it's not usually that they want to kind of trick you with the wording. And for those who don't know, Ralph is here with us at the Amber Book. And Ralph not only is an architect and taking his exams like you are, but Ralph, when he was in high school, finished 9th in the country in a horticulture competition. He was the 9th best
forestry.
Oh, and 8th in forestry. So Ralph is a site whiz, and that's one of the many reasons we have him on our team. Okay, now go. You have 5 minutes. All right, pencils down. What do we got? An architect is developing a 275-acre site with a goal for the entire site of 21 units per acre. That's going to be our density. He's developed 75 acres of the site so far at 14 units per acre. What should the density be in units per acre for the remaining not yet developed portion? All right, let's figure this out. So this is actually a little bit more complex than the others. And before we start, let's do a theoretical. All right, let's say that I run around the track. Let's say that we have to do a relay, and it doesn't matter how much we split it up. Like I can run a little bit and you can run a lot of it, or we can each run half or whatever. And so if we have a situation where I run it in 2 minutes, I run around the track in 2 minutes, and you run around the track in 1 minute, and we're a relay, and we have to go twice around the track in total, then you can imagine that it's pretty, if I do once around the track and you do once around the track, we know that our pace around the track is going to be, our composite pace around the track is going to be what, 1.5 minutes, right? So we can take we can go, halfway around the track times 2 minutes for me, plus I'm sorry, not halfway, but half the race, 2 minutes for me to go once around the track, and half the race times 1 minute for you. And that's equal to, this is equal to 1, and this is equal to 1/2. And we're going to add them together, and it's a minute. Our pace is 1.5 minutes per lap. That's going to be our composite pace. Now, if I run more of it than you do, let's say I run 3/4 of the race and you only run 1/4 of the race. So now we have me running 3/4 of the race. So it's 3/4 of the race times 2. And you're running 1/4 of the race times 1 minute per lap. That's your pace. What's the composite pace then? Well, 3/4 times 2 is 1.5. And 1/4 times 1 is 1/4. And we add those together and we get 1.75. Our composite pace has slowed down. Why? Because now I did 3/4 of the race and I'm slower than you. So it makes sense that our composite is going to be closer to my pace of 2 minutes than to your pace of 1 minute. And so you want to remember that, because what we want to do, there's lots of ways to solve this problem, but I think probably the easiest to remember in a high stakes test where you can't bring in notes is that we're going to always take the proportion, and this applies to, you can do this for composite insulation, like for R value, there's a lot of things you can, or sorry, U value, there's a lot of things you can do this with, but we could take the proportion and multiply it by the value and add the proportion and multiply it by the value, and we get the composite. Proportion times value plus proportion times value. So what do we have here? We have a 275-acre site. For the entire site, the goal is 21 units per acre. That's our desired value. 75 acres so far at 14 units per acre. Now, again, never just look at that as numbers. That means a small portion, not a tiny portion, but a small portion, 75 of the 275 acres, has been developed so far. Is it denser or less dense than our target? It's less dense. It's 14 units per acre so far. So the rest of our site, what do we know about the rest of our site? Go ahead and put it in the chat. What's the density going to be like in the rest of the site? You at least know one thing about it. If we did a little bit of the site at less density, what is the rest of the site going to be? Yeah, it's going to be higher. It's going to be something higher than 21. Now, it may not be much higher because we've only developed a little bit of the site, but it's going to be higher. So remember, what we want to do is we want to multiply the proportion times the value plus the proportion times the value is the composite value. So the proportion that we've done so far is 75 over 275. And the value we've done so far is 14 units per acre. And we can add that to the proportion that we still have to do, which is 200 over 275, because we've only done 75. So 275 minus 75 is 200 times x, what we're trying to solve for. What's the proportion? What's the value of the rest of the site is going to be equal to 21. All right. Now, 14 times 75 over 275 is going to give you 3.8. If you ran that out, you can check me on your calculator if you'd like. Plus 200 over 275 is 0.73 times x is equal to 21. And then we can subtract 3.8 from both sides. And we wind up with 0.73x is equal to 21 minus 3.8 is 17.2. Then we can divide both sides by 0.73. And we get x is equal to 23.6 units per acre. Now, again, don't just look at that and be like, got the answer. You have to make sure it makes sense, because it's so easy to screw up one of these things. Just even if you got it right, it's so easy to screw it up by, messing with a decimal point or something like that. And also, like, it should make sense. And that way, you did it right. You don't have to flag the question and come back to it. So we had already determined that we have to be more dense than 21 for the rest of it, maybe a bit more dense. And we are. 23.6 is a bit more dense than 21. So that's our answer, 23.6. All right, now for our last one, I'm only going to give you 2 minutes for it. So get ready to go. Ready, set. It won't let me go to the next one. You son of a bitch. There we go. Go.
And Michael, on that last problem, you'd probably round up to 24 on the exam, right?
You can put that number. The exam will know in the background.
Well, if it's not a multiple choice, yeah. But if it's a
yeah. Again, people are usually concerned that there's going to be complex structural calculations involved, and there will be. But of the 550 questions you see, you're going to only see a few, maybe 2 or 3 complex structural calculations. And one of the things we preach is you want to focus on yield. You want to get the most extra questions right per unit of hour studying or whatever. Now, there are 1 in 6 of you, in my experience, who love studying. And for you guys, go nuts on the complex stuff. I'm the same way. I'm like you. But for the 5 out of 6 of you who just want to get this done and want to get licensed, and then you can study more after that, there's no rule saying you can't, then my advice to you is to not freak out about the most complex math problems and actually get really quick at the kind of simplest. And this is certainly one of the simplest. So you need to know there's 2,000 pounds in a ton. So we have 50 tons times 2,000 pounds. And we run that out and we get 100,000 pounds. Because we want to put it in pounds per square foot. And we have a foundation, a footing that is distributing the load to the soil that's 6 feet by 8.5 feet. And that winds up giving us 51 square feet. The answer is actually quite straightforward. It's pounds per square foot. So we'll take this and we'll say pounds, 100,000 pounds, and divide it by this, which is 51 square feet. And our answer is 1,961 pounds per square foot. Now, again, don't just look at that and say, okay, that's what it is. What we're talking about is we're saying, okay, this is 6 foot by 8 foot. I don't know, I drew it in perspective, but the horizon line's a little weird, so it's a little confusing. But basically, you have 51 square foot from this column is bearing on 51 square foot footer, and that footer is then putting pressure on the soil. And we want to know how much pressure we're putting on the soil because we don't want to overload the soil and have a situation like we have in San Francisco right now, where the building is leaning, right? There's too much pressure on the soil. So we want to know, we know how much, we don't know, but we estimate based on borings, how much pressure the soil can hold, can resist the competency of the soil. And so we're going to say, okay, in a square foot of that, so just one little square foot down here of that 51 square foot footing, we are pushing down with a force of 1,961 square feet. Now, I'm putting in the chat right now a link. I make this available to Amber Book subscribers, but I make it available to anyone who ever wants to talk to me. You can click on that link and you can schedule a 20-minute session with me, and we can talk about content, or we can talk about strategy, or I can walk you back from the ledge, which I seem to do a lot of on these things. I started doing these weekly to talk about content, but 3/4 of the conversations, maybe more, are just people who are looking for a strategy to get through the exams. And I have some advice about that as well. So you can click on that and you can schedule a meeting with me. So we got through PcM, we got through PjM, we got through PA, and this, of course, was PPD. The other two will have to wait till maybe another conference. Thank you guys so much. I think we have a minute or two for questions. Does that sound right, Joanna? Yeah.
Yeah, we could definitely squeeze in a question. I'm sure there's going to be a lot of them. People always love to ask you questions, Michael.
Well, I like the comments. These are fun to read. You're an amazing human, Michael. The positivity at this conference, I always have to take it with a grain of salt, because I think, are they really saying an amazing human, or do they just come from Marley and just had like a lot of positivity and are giving it to me? But I will take you at your word that I am an amazing human, and I'm going to put that on my bumper sticker.
We'll get you an award, Amazing Human Being Award.
Amazing human. Okay, so does anyone have a question?
I was going to say the chat's going fast. If anyone wants to do like the raise your hand, or just go ahead and unmute if they had a question.
Go ahead and unmute yourself, because we don't have much time.
Brett had one in the chat here.
Yep, that'll be our question. How much for a rounding error? Like I said, don't worry about it. So a lot of people stress out over it. Generally, this is not the problem that you're going to see in questions where you rounded wrong. If the answer was 1961, in the background, the exam will probably accept anything from, I'm making these numbers up, but 1950 to 2000. Because frankly, the difference of 50 pounds on soil really doesn't matter that much. And you might have rounded something or not rounded something. So there'll be, no matter what you're not going to screw up the rounding. And people will also freak out. They're like, do we round up or down in the sense of life safety? Well, it depends. If the number in real life, it depends. If the number is the occupancy load of a banquet room, and your calculation comes up to 511.2, or let's say 511.7. So you figured out that banquet room can have 511.7 people. Well, you're going to run down because we don't want to have more people than we're allowed. So even though it's closer to 512, you're going to say it's 511 because common sense says we don't want to have 512 because that's more people than we're allowed. 512 is more than 511.7. Likewise, if you figure out that a stairwell has to be 47 inches wide, if you figure out it has to be 47.2 inches wide, and you want to obviously round up. You want a wider stairwell so people can get out in a fire, because if it has to be a minimum of 47.2 inches wide, then 47 inches isn't going to cut it. But the good news is, in my experience, this is not an issue for the exam. They just don't do this kind of thing. They're tricky, but they're not picky. And when they're tricky, they're generally trying to see if you know something that's not intuitive. They're not trying to, slip something. Now, there are exceptions. There's lots of bogus questions, but you can't study for those anyway. There's no studying for bogus questions by practicing with bogus questions. It's so unlikely that you're going to get a bogus question in the exact same way in your study materials that is in the exam. So I want you to study with good questions and know that you want to shoot for the middle and not close your eyes and hope that you get a bullseye.